Okay, now the chapter on infinite series is full of different tests that we can use to test whether a given series is convergent or divergent. Now we have already learned one way of checking one type of series for which we can easily check whether the series is divergent or convergent, and that's a geometric series. We learned that in a geometric series, if the ratio is less than 1 or is between -1 and 1, then the series is convergent, and if the ratio is greater than 1, then the series is divergent. Now the next test that we are going to learn is the so-called divergence test. Now you should remember that this test will only test for divergence. I mean, you can never check whether a series is convergent. You can never prove whether a series is convergent from this test. Now what this says is very simple. Now if you have an infinite series, okay, inside the sigma, which makes it a series, there is a sequence. And now if you take the sequence out, okay, and if one or two things, this or this, will happen to that sequence, then the test says that the series is divergent. So you've got to be very careful not to mix up the sequence and the series. Now what are the two things? For example, if you take the sequence and the limit of the sequence is not equal to 0, then straight away the series will diverge. Or if the sequence itself diverges, then too the series will diverge. So once again I will tell you, if you take out the sequence, right, and if the sequence has a limit and that limit is not equal to 0, then the series will diverge. That's one case. Or if the sequence itself diverges, then automatically the series will diverge. Now this is the very, now remember when we did integration, I told you before you try any heavy duty technique to nail an integral, right, you should always try a use substitution and see. So likewise, before we'll be learning a lot of tests in the days to come to check whether a series is convergence or divergence, but I would strongly recommend that before you use any of those tests, use the divergence test. What you do is you just take the sequence inside and test and see whether it has a non-zero limit or whether the sequence is divergent. One of the two. One is enough. And if one of the two is satisfied, then straight away we are done. There is nothing else to be done. The series is divergent. Okay, now let's look at an example. Now let's look at the first example, sigma n over n plus 1. Okay, this is of a series. Now let's extract the sequence. What's the sequence? The sequence is n over n plus 1. Now how do we find the limit of, the next step is to find the limit of this sequence. Now there are many ways of doing that. One way would be to divide by the largest power of the denominator, which will be n, and you divide out by n and do it. Okay, or else kind of an easy but a kind of a overkill method would be to just use L'Hopital's rule. Because why? Because the top is n goes to infinity, the bottom is n plus 1, that too goes to infinity, so infinity over infinity means a good candidate for the L'Hopital's rule. So if you want to find the limit of this, then the limit of this would be, first to differentiate this. If you differentiate n, you just get 1, and if you differentiate n plus 1 also, you get 1. So you get 1 over 1, which will be just 1. So the limit of this sequence is 1. Okay, so is the limit of the sequence equal to 0? No. because it is equal to 1. It is not equal to 0. So the limit of the sequence is not equal to 0. So then it falls on to this branch. The limit of an is not equal to 0. Then straight away we can say that the series sigma an will diverge. Okay, so we can now say therefore that this series will diverge. Okay, so once again, what did we do? We looked at the series and then we extracted the sequence and we use L'Hopital's rule to show that the limit of the sequence is equal to 1, and specifically we showed that the limit of the sequence is not 0. And then we are done, because if the limit of the sequence is not 0, then the series is divergent. Now for my second example, let's look at another series. Let's take a little bit more complicated, but don't worry. So you want to check the convergence and divergence of this series. Okay, so let's extract the sequence and then let's apply L'Hopital's rule. So if we apply L'Hopital's rule, can I use L'Hopital's rule because the top goes to infinity independently and the bottom also goes to infinity independently as n becomes large. So therefore it's a good candidate for L'Hopital's rule. So what we do is we differentiate the top, in which case we get what? 4n plus 3. Okay, and then if we differentiate the bottom, we'll get what? 10n. Well, what's the limit of this? Well, you can differentiate it again, right? In which case you get the derivative of 4n plus 3 is 4, and the derivative of 10 is 10, so we have 4 over 10. So once again we got the limit of n to be 4 over 10, 4 tenths. Now is that equal to 0? Nope, it is not equal to 0. So the limit of the sequence is not equal to 0. So straight away we can say that the series will diverge. Why? Because the limit of n is not equal to 0. Alright, now let's look at a third example. Now let's look at this one. Okay, so now once again we need to check the convergence and divergence of the series. So to do is we take the sequence and we look at the limit of the sequence. So we have limit of n over n squared plus 1. Okay, and then how do we find the limit of this one? What we do is we use L'Hopital's rule, and then the limit of the top is 1 and the limit of the bottom is 2n. So we take the limit of that. Now what we have is the limit of top is 1 and the limit of the bottom is 2n, and that is a number over infinity which is equal to 0. Now the limit is equal to 0. What do we do now? Now remember, the test is only true if the limit is not equal to 0 or the sequence diverges. If the limit is equal to 0, then the test is no longer valid. So we cannot get any conclusions from the test. So what's the answer? Now when you go to an exam, you should not write the test fails. What you should do is then find a test that will work. Well, for this particular example, we will find a test very shortly that will work, but as far as this test is concerned, it will not work. So the divergence test will fail here. Now, as a video exercise, I will ask you to check the convergence and divergence of this particular series. Alright guys, so that's it for this video tutorial. We'll see you in class tomorrow.